I'm just going to go over 7 of the questions in the 1997 Junior Maths Challenge. Questions are 1, 4, 7, 8, 9 and 14 and 15. So let's start with question 1. 4 lamp posts are in a straight line. The distance from each post to the next is 25 metres. What's the distance from the first post to the last? This is a sort of question which I like drawing a diagram for. 4 lamp posts, I'll just use a straight line for them, in a straight line. So I have one there, one there, one there and one there. That's my 4 lamp posts. The distance from each post to the next is 25 metres. So we've got that distance and that distance, so each 25 metres. Now with the diagram that makes this question easy. Actually, what is the distance from the first post to the last? Well, again, you can clearly see it's 75 metres, so it's question C. Question 4, which of the following expressions gives the largest number? This isn't one you solve via a diagram, this is one you just do the calculation. Obviously you don't have a calculator, so you've got to work a technique out which is going to give you the answer. I don't want to do all those calculations, I look for a quick way. BODMAS must be applied. I go and spot some large numbers here, like that's a 9 times 7, which is 63, then I'm adding this bit. In fact, I've worked that one out straight away, haven't I? That's 63 and 9, that's 72. Now that I can admit I don't even have to do that calculation, there's no way that's going to be 72, so it's not B. This one, largest, is 9, that's going to be a lot smaller without actually doing it. This stands out, there's your first bit, it's 9 times 9, that's 81. So that's going to be bigger, so it's actually not A. And this one here is 9 times 7, which is 63, and on 72, that's 73. But like I said, just this part of the calculation is 81. So then I've got another 8 is 89, so it's D. I was trying to do that calculation without actually working out absolutely everything of everything, because Math Challenge is about doing calculations efficiently, spotting quick methods. If quick methods aren't available, you just work your way through things, but always look for the quick method if possible. Question 7 shouldn't actually have to be done, but I'll do it just in case some of you don't know the test for a multiple of 3. The test for a multiple of 3 is do the digits add up to a multiple of 3? So the question says which of these numbers is not a multiple of 3? So which one of them have digits which do not add up to a multiple of 3? So I guess I just have to go through adding up the digits, and maybe I can have an intuitive guess, like maybe I can spot that one there is definitely 3, so I'm looking for not, so it's not that one. I just spotted that's 3 and that 2 and 4 makes 6, so that's a total of 9, though it's not that one. I'm just guessing this one, that doesn't look like it's going to be a multiple of 3, so let's do that. That's 4 and 5, that's 9. In fact, we can say those actually add up to a multiple of 3, don't they? And that's another multiple of 3 in there, and those two make 15. They're all multiples of 3s. That's going to be a multiple of 3. Check that. 3 is a multiple of 3. That's a multiple of 3. 4 plus 5 is a multiple of 3. So it's not that. It leaves us E. Let's just check. 9 is a multiple of 3. The 6 is a multiple of 3. The 5 and the 7 make 12, which is a multiple of 3, then we've got 8 left over. So it is actually E. Those digits will not add up to a number which is a multiple of 3. Question 8, I think, is probably a listing question. It says I've got 2 spinners, one is a square, the other is a regular pentagon. Both spinners are spun at the same time and the 2 scores obtained are added together. Added. How many possible totals are there? Now they're added together. Let's start with this one here. Now this one could land on a 1, a 2, a 3 or a 4. And this one here could land on a 1, a 2, a 3, 4 or 5. So I'm going to start off assuming this is going to land on a 1. So if this one lands on a 1, and then see what the other could do. The other one could land on a 1, which is going to give us a total of 2. It could be 1 and a 2, which is a 3, 1 and a 3 is 4, 1 and 4 is 5, and 1 and 5 is 6. Now I've written down each of those, they're different totals. So I've got 1, 2, 3, 4, 5 different totals so far. Let's suppose now the first spinner lands on 2. I could have the same things with the second spinner, so it could be 2 plus 1. I don't have to work that out actually, because that's 3. It's going to happen. It's going to already be here, so that doesn't matter. So 2 plus 2, that's 4 already here. 2 plus 3 is 5. 2 plus... In fact, do I have to work all of these out? I think I've actually already spotted what's going to happen here, because that's going to be 2 plus 4 is 6, which I've already got, and this one's going to be 2 plus 5, which is 7. In this, with the 2's, I've only got one new number. All the others are existing scores, and I think that's going to happen with the others. Like if I do 3 for the first spinner and I do 1, that's going to be 4. I've already got 3 plus 2 is going to be the 5, which I've already got. 3 plus 3 is 6. 3 plus 4 is 7, already got. So it's going to be 3 plus 5. It's going to give me 8, and likewise the only one when I have 4 to start with is going to be the 4 plus 5, which is going to be 9. I'm happy that I don't have to list out all the others. So the total number of different scores are 1, 2, 3, 4, 5, 6, 7 and 8 different scores. That's D. Question 9 is a fraction division. Sort of question I like. I'll first of all just look at that. This is a calculation I'm just going to do because I can. So it's actually 4 over, and I'm going to work out the bottom bit. That's 1 minus 3/4. That's going to be a quarter. 1 divided by a quarter. Yeah, 1 over a quarter means 1 divided by a quarter. Now if I write that out in a more familiar way, I could write that as 4 divided by a quarter. 1 over a quarter is the same as 4 divided by a quarter. And you think, hang on, this is just multiplying fractions. How do you work out 4 divided by a quarter? Well, you change it to times and flip it. So that is actually equal to 4 times, not divide by 1/4, it's times 4 over 1, which is 4 times 4, which equals 16 over 1. 16 is your answer. Question 14 tends to be a favourite type of question, which involves fractions. In this case, I'm going to actually evaluate each of the fractions, work out what they are. This is 3 at the top and 5 at the bottom. This one is going to be 6/5. This one's going to be 3/10. This one's 5/4, and this one is 7/6. Now sometimes when you actually evaluate fractions, you sort of get some pattern in the denominators or pattern in the numerators. I can't actually see that pattern here. It looked like there's going to be a pattern there, but there's not one. What does it say? Which fraction is the biggest? Well, once I've got my fractions, I tend to do these by a process of elimination. So is there one which is obvious? I can just go and compare these two, I suppose. So which one of these two is the biggest? I'm looking for the biggest. So well, clearly 6 over 5 is more than 1. This one is less than 1, so I can actually eliminate that one. In fact, I can eliminate anything under 1 because I've got 6 over 5. That's more than 1. It's 1 point something. So that's going to be less than 1. Eliminate that. Any others? No. So I've managed to eliminate 2 because they're too small. This is 6 over 5, 5 over 4, 7 over 6. Do you notice the numerator is 1 more than the denominator in each one of those cases? I want the biggest fraction. Now if I consider fifths, fifths are smaller than quarters, and a quarter is bigger than the sixth. That can be written as 1 1/5, and this can be written as 1 1/4, and this can be written as 1 1/6. And I know that a quarter is bigger than a fifth and is also bigger than a sixth, so it's got to be this. This is the answer, which is D. Question 15, the last question that I'm going to go through. Donna's making a coloured tower show, and this is quite, we're getting to 15 now. It takes time to actually interpret them. Donna's making coloured tower as shown. She has 36 small cubes with equal numbers of red, blue and yellow. So just remember that's red equals blue equals yellow. Each row is of one colour, and no two rows which are next to each other are of the same colour. The top 3 rows are coloured as indicated. What colour must the bottom row be? So I'm trying to work out this here. Well, first of all, it says equal numbers. Well, how many are there altogether then? I think I've got to ask that question. Well, let's can count them all up, or I'm going to try and find a quicker way because counting is quite time consuming. This is 1 in there, there's 2 there, 3 there, that's going to be 4, there's 5, 6, 7 and 8 in that row. So if I add up 8 and 7, and that comes to 36. So there's 36 in total, and if there's 3 different colours, equal numbers of each colour, they're 12 of each colour. Now, knowing there's 12 of each colour might help me. Let's go and have a look now and said, okay, let's go and have a look at, well, we start with the red or the blue. Let's start with the blue because there's less of them. If there's 2 blues there, the next row that blue can go in can be here, which can be 4. I could have those being blue. That would use up 6. And then I'd have 6 left, in which case the next row they would have to be blues. Remember, we've got to fill a whole row, so those there could all be blues. It would fit. If this wasn't a blue row, I'd have to have 5 there, and that would make a total of those 5 and those 2, which makes 7, and another row of 5, so that wouldn't be possible to have 2 rows of 5. So in fact I know that that must be the only possibility, that they are blues in those 2 rows. It doesn't help me though. It says what colour must the bottom row be. I know it's not blue, I suppose. That helps me. Let's have a look at the red. We've got reds already marked in. You know, I haven't got a clue where the yellows would be because there's no yellows on there. But reds, how many have I've used up 4 reds, so there's 8 reds left. 8 reds to fit in. Now, reds, they couldn't go on that row even if blues weren't there because they'd be next to those. So this is the soonest red could be in there, which is 5 reds. And since we've already used 4 plus 5 is 9, and I'd have 3 left, so it's not possible. In fact, I've used 4. That means I've got 8 reds left, and they've got to go on 2 rows. Well, they don't have to go on 2 rows, but if they went there, they can't go on that row because they'd have to go on a row 3. They can't go 7 there because they'd 1 left and have to go up there. It's, the only option is to have the 8 reds all on a row down at the bottom. A row of 8 on their own, so that's 8 and 3 and 1 make the 12. So the answer to this one is the bottom row is red.